going to be looking at finding missing angles in regular 2D shapes. So this is the type of question that we want you to be able to answer very, very soon, and this was taken from a National 5 exam paper. So first of all, regular polygons are 2D shapes where all sides have the same length. Now, an interesting property about regular polygons is also that all the interior angles, all the angles inside the shape, are also the same size. So regular polygons, all sides have the same length, but also all angles are the same. So let's take this example of the pentagon. Now, there are a couple different ways that we could do this. And what we're going to do now is investigate the interior angles of this pentagon. So I found the center point, and I'm going to draw a line to each of the 5 vertices, each of the 5 corners. And what we get are 5 triangles, 5 congruent triangles. And what I mean by congruent are they're all identical, they're all exactly the same. So let's focus our attention on this here. Okay, around a point, all of the angles add up to 360 degrees. So if I take that 360 degrees and split it 5 ways, one for each of the triangles that I've made, I have an angle of 72 degrees. So that angle there, for example, is 72. I then want to focus your attention on that one triangle. I've put little markers in to indicate that those 2 sides have the same length. So that means that the angles opposite those 2 sides are also the same size. So this angle here, which is opposite this side, and this angle here, which is opposite that side, must be the same size. So 180 minus 72 is 108. So 108 degrees has to be split evenly between those 2 angles. So 108 divided by 2 is 54. So those 2 angles there must be 54 degrees. I can go around the perimeter of this pentagon now and mark in all of the 54 degree angles. And I want you to focus your attention up here, because what I can do is I can replace the 2 54 degree angles with 108. So I can add the 2 54 degrees to make 108. So that information there on the screen now is what I want you to be able to focus on. Okay, I want you to be able to think about how we work that out and possibly be able to remember it, but definitely how we worked that out. So we worked out from the middle out to the edge of the pentagon. So all of those interior angles are measured at 108 degrees, and the total of all of those interior angles is 540. So if I added up 108, 108, 108, 108 and 108, or just multiplied 108 by 5, we would get 540 degrees. We can adopt a similar strategy for a hexagon, a 6-sided shape. So finding the centre point, marking in the triangles, finding the angle at the centre, so 360 divided by 6 this time, because I have 6 triangles, so each of those must be 60. We have an isosceles triangle, which means that these angles have got to be the same size because they're opposite sides that are the same length as each other. So 180 minus 60 is 120. Share the 120 2 ways and we get 60. So actually, this triangle is an equilateral triangle because all the angles are the same. So we can go around the perimeter of the hexagon again and then add up that interior angle. So 60 add 60 is 120. And again, all of the interior angles there are 120 degrees. And if we do 120 times 6, we can find out that the total interior angles is 720 degrees. So this is a useful summary sheet of different polygons. You might want to copy that down. And you might want to pause the video at this point to try and find out the size in these two separate diagrams of the purple angle. So use the sheet, I've put the sheet at the top right here to help you. Try and find these purple angles, pause the video now and I'll go over the answers. Okay, so in that top left diagram here, I know that this angle here is 120 degrees. It's inside a hexagon, and I know that all the interior angles of a hexagon make 120 degrees. So that's illustrated in our wee diagram here. The pentagon up here has an interior angle of 108. And what we can see here between the purple, the pink and the green is that we have a full turn. And we know that around a full turn, we have 360 degrees. Therefore, this angle here needs to be 132. If we have a look at this question here, I've highlighted the pentagon, which means that this angle needs to be 108. This angle here also needs to be 108. The pink angle that I've just marked in and the green angle add up to 180 degrees. They make a straight line. So that needs to be 72. Similarly, this angle here, for the same reason, also needs to be 72. So we can use an empty number line to find the purple angle by doing 72, add 72, which makes 144, and then figuring out what we need to add on to that to make 180. So that would need to be 36.